Hello, everybody. Today I can determine if an object is fair by determining if its outcome is inside the confidence interval of a fair object. If I go to flip a coin, the probability that it lands on heads is 0.5 and tails is 0.5 if it's a fair coin. If it's not a fair coin, if it's weighted a certain way so it's more likely to fall on one side than the other, it's an unfair coin. So how do I determine if it's a fair coin or not? Well, first, I need to find the proportion of my coin or spinner or dice or whatever it is. So Anne has a coin. She flipped it 100 times and obtained 73 heads. So Anne got 73 out of 100. We know that probability states that she should get 50 out of 100, but there's no guarantee that's actually going to happen. So 73 seems kind of high. Well, is that a value that could be obtained due to random chance of a fair coin? Well, I need to find the confidence interval of a fair coin. So they ran the simulation 200 times of 100 fair coin flips. All the proportions are found. We know that our confidence interval is the mean plus and minus 2 times the standard deviation. So I have 0.497 plus 2 times 0.050 and 0.497 minus 2 times 0.050. You can use the calculator. I'm not. Let's be efficient here. My confidence interval is 0.397 to 0.597. Now I'm going to take a nice long educational pause right now to get your attention back, because it's very important for this lesson that you understand what I just found. What I just found is the range of expected values of a fair coin. What I just found is the range of expected values of a fair coin. If I flip a fair coin 100 times, then it's expected that I'm going to get between 0.397 and 0.597 proportion of heads. Is Anne's result an expected value of a fair coin? No. Therefore, the coin is unfair because 0.73 is not inside the range of values of a fair coin. You can just write that it's unfair because 0.73 is not inside the confidence interval to be consistent with the other lessons. But for fair, I like to write it that way because every time I say it inside my head, it kind of reinforces it. This is the range of expected values of a fair coin. If it's a fair coin, this is the outputs I should get. I didn't get that, therefore the coin is unfair. Let's take a look at one more. Robin, let's do something that's not a coin. Juanita rolls a 6-sided die and recorded that it landed on 6 5 times out of 50. So out of 50 rolls, she only got 5 of them. So her proportion is 5 out of 50. We can use a calculator if we need to. That's 0.1. And she's like, well, come on, man. I spun it 50 times. I should have gotten more than 5. So she questioned whether the die was fair. So I need to find the range of expected values of landing on a 6 in a fair die. So she ran a computer simulation of 1,000 samples. The mean was 0.159. The standard deviation was 0.102. So we need to find the range of expected values of the fair die. We need to find the confidence interval. So 0.159 plus 2 times 0.102, 0.159 minus 2 times 0.102. I'll pull up the calculator for this one. So the calculator gives me 0.159 plus 2 times 0.102 minus. So I have a negative 0.045 to 0.363. So this is the range of expected values of landing on a 6 at 50 spins. So what did Juanita get? Well, Juanita got 0.10. Is 0.10 an expected value of a fair die? Yes. 0.1 or 0.100 is in between. So that is an expected value of a fair die. Therefore, is her die fair? Yes. 0.1 is in the range of expected values of a fair die. 0.1 is inside the confidence interval. So to determine if an object is fair, I need to see what the output is. In this case, 5 out of 50.1. In this case, 73 out of 100.73. I need to find the confidence interval for a fair object, the range of expected values for a fair coin, the range of expected values for a fair die. If Anne's output is in the range of expected values of a fair coin, then it's fair. It's not, so it's not. If Juanita's output 0.1 is in the range of expected values of a fair die, it's fair. It is, so it is fair. That's it. Find the confidence interval, see if their output is inside. If it's inside, it's fair because it's in the range of expected values of a fair object. If it's not in the range of expected values of a fair object, then it's not. Goodbye.